Hello and welcome to this lesson. We are talking about potential energy. So last time we talked about kinetic energy, which is the energy associated with motion. And we've also discussed in the past about something called conservation of energy, which says that the energy used in a system must remain constant. So you cannot create or destroy energy. So if we are creating some kind of kinetic energy, and I use the word create in quotes, it means that there has to be some give or take of energy. So where does that energy come from? This is the idea of potential energy. We're going to start with a simple system here. Suppose I have some object that starts at some height, we'll call it y1, and it's moved up a distance of h to a location y2. Okay, we're moving in the vertical direction, which means that we are moving against the force of gravity. So this is the force of our hand, say, the external force, ext. So you can think already by seeing this, you should be considering our definition of work. So what is the external work? Well, we're going to take that external force that we've had. Actually, we're not going to need the vectors here because remember, work is a scalar quantity. And we're going to multiply it times the displacement because the force here is in the same direction as our displacement, so we can keep that. D and F the same. And well, because they're going in the same direction, we can say cosine of 0 degrees. Okay, well, the force that we've used here, you can see, is equal and opposite to mg. If we define the force of gravity to be negative, then our force here would be positive, and the displacement was a value of h, the height. Okay. In other words, we could also write more generally as the change in the height, y2 minus y1, which is h in our case. Okay, so this is actually the work associated with what we've done here moving, and we've seen this before. Let's talk about what has happened. So the gravity has also a certain amount of energy associated with it. So let's talk about that. Let's talk about the work of gravity. So gravity is pushing back on us as we're going upward, and it's going to be equal and opposite in magnitude, okay? So this actually tells us something really important. It's telling us something about the energy available. Once we lift this box up to this height, it now has the potential of a certain amount of energy, this quantity, to move back down. We've given this energy, in a sense, from our external force to the box. It now has the potential, if we let go, to fall back down. So let's write that as PE for potential energy of gravity, mgy. Okay. So what is y in this case? Y is actually the same value as h, and sometimes you will see me write h instead of y here. But it just means some height above a reference point. Okay, so in our case, y2 minus y1, we often will just say that y1 is 0, and so we just call y2 y. Okay, this is the amount of energy that the box now has potentially to use. The best way to think about it is it's at some height, there's some reference point here that it could fall down to. If we let go, this energy is now available to the box to fall down, to move it down in this direction. Okay, Notice it's a positive energy, okay? We did have a negative sign here, but that was only because the gravity was working against the direction of displacement, okay? But the energy that is now available to it would be positive, because if we let go, the box is going to fall in this direction, which will be in the same direction as the displacement. So that energy would be positive, available to that. Okay, so this is, explicitly, this is the gravitational potential energy. And there are more types of potential energy, but this one is just associated with the energy available from gravity. When we lift an object off the surface, it gains this amount of energy. We can have potential energy from any type of situation in which energy is available but not being used. Hence the word potential. Okay, it's not a real energy. It's telling us what energy is possible if the situation changes. Okay, usually we just remove a constraint, a hand, or if you compress a spring, it will have a potential energy, and when you let go of that spring, that energy can be used and turned into kinetic energy. So suppose we have a roller coaster here. Question is, if this is a 1,000 kilogram roller coaster car, and it moves from position 1 to position 2 to position 3, what is the gravitational potential energy at points 2 and 3 relative to point 1? Okay, when we say relative, that means that this is our reference point. Okay, so here our potential energy would be 0. And then if we go up here, we've gained some potential energy. Okay, and we will see what happens. You might be able to guess what will happen at position 3 here. Okay, so position 2, let's start with this. The potential energy is going to equal mgy2. Remember, because this here is at value 0, our y value is 0, so we just have a potential energy positive of y2 in this direction. So it's simply just 1,000 times gravity times the height, 10 meters, and we get 9.8 times 10 to the 4. And our units are joules for potential energy. It is an energy. We quantify it as being an energy. Okay, so that's our value for PE2. And how about for 3? Okay, so now we've gone down a height of 15 meters. So what does this mean that we have a negative potential energy? It means that we've taken away its ability to fall, basically, because it's at a lower height now. So if it were to fall to some position 4, even lower than 3, it would not have as much energy to do that. Okay. What is the change in potential energy when the car goes from point 2 to point 3? Well, simply we take PE3 minus PE2. That is the change in potential energy, okay? So you can think of it as being change in potential energy, and maybe we write it like this. So we already solved these. Negative 1.5 times 10 to the 5 joules minus 9.8 times 10 to the 4 joules. So just subtract those quantities, we get negative 2.5 times 10 to the 5 joules. Okay, simple as that. So the potential energy decreased from this value to this value, and that's how much we lost. Okay, last question. Okay, so what if we say that this now is equal to our reference point of a height 0. So in this case, y1 would have a height, okay, we can call this y3, right? y1 is going to have a height of 15 meters, and y2 would have a height of 25 meters. Okay, question is, what is the potential energy here at 1? Okay, so you can see it's a positive potential energy. We've gone up to height 1. We now have this potential. And at y2, okay, so now we're going to do the same question again. What is the change in potential energy going from 2 to 3? Okay, so we're going to do what we did before. It means we started here and we go to position 3, okay? Well, at position 2, we have this amount of potential energy. So if we go back down to 0, height 0, you can imagine we're losing all of that potential energy. So of course, this value is 0 because we're at our reference point, and this is just 2.5 times 10 to the 5 joules. So we just lose all the potential energy that we started with.